Hey guys, today I'm going to show you how to install Gentoo Linux. I'm going to cover everything step by step in detail, and I'm going to show you what worked for me. Almost everything in this video is being copy pasted from my guide that I've posted on my site, so you can just check the link in the description for that guide and you can copy and paste the same things that I'm doing and basically follow the exact same process that I'm following. So we're doing a minimal install. This is just to get the basic system up and running, so no GUI. And this is going to be an OpenRC based install, not systemd based. This is going to be text based to start, but I'm going to show you the options that you would select to make it easier to install a GUI with X11 and Wayland on top of this later on. Now, I'm doing this as a voiceover, so all the audio and speaking you hear in this video, including in the parts where you're watching me type things on the terminal, this is all recorded after the fact. I recorded that actual footage ahead of time just to get it installed first. Now, I'm going to be using Nano instead of Vim most of the time. This lowers the barrier of entry for new people, and it's also available by default on the Gentoo install media, so that's why I made that choice. Now, what hardware did I use? I'm installing this on a Proxmox virtual machine running on an old Mac Mini in my closet. So it has limited resources for CPU cores and 6 gigs of RAM allocated to the VM. Now, I ran into some minor UEFI issues. I'm going to show you how to fix those too. That was a pretty interesting process, so keep watching for that. Now, let's jump right into it. Now, the steps we're going to follow, we're going to cover these steps in order. So, install media and getting started, disk partitioning and file systems, the network, temporary network setup for the installation, tarball and mirrors, mount the file systems and chroot, update and Portage setup, users and important tools, file system table, locale and time zone, kernel, bootloader, network, finish and wrap up the install, and then install some basic standard components you should have on any system. All right, so the first section, install media and getting started. Minimal is okay, but the GUI installer is better for copy and paste. So whichever install disk that you want to choose, that's up to you. Now, one I guess pro tip here is that you can actually launch the SSHD daemon on it and just log in remotely with SSH if you have another system to install from. So if you use the minimal installer and you still want to copy and paste, you can start up the SSHD daemon on your VM or whatever system you're running it on, so long as you're on the network, and you can just SSH over to it and run everything from another system. So you can see here on the downloads page, here's the minimal install CD and the live GUI USB image. So you have both of those available to download. Just pick the one you like. All right, so here we're going to actually go ahead and click on this and start downloading it. And there we go. You can see that it's downloading and it's going to be done. I'm going to fast forward this and there we go. It finished downloading. And let's move that out of the way there. And let's actually start flashing this. So we're going to say flash from file, move this over onto the recorded area and select the ISO image that we downloaded. And basically going to select our disk here our USB drive that we want to use as our installer, and hit select and hit flash. Now, this is not the actual USB disk I'm going to use. I'm just showing you how you could create this. So I'm just bringing you through the process. I'm actually going to transfer the ISO directly over to Proxmox and load it up in the VM. But I just wanted to show you this part just so you know how you can make a USB drive yourself. So I'm using a tool called Balena Etcher. You can get it on Linux and I believe also Mac OS and Windows. So I'd recommend using that tool. Anyways, here we have a VM starting up. And we are going to bring this guy right up here. And I'm going to check and see that SSHD is not running. So I'm going to go ahead and start it up. So RC service SSHD start. And remember, check the link in the description for a document where you can copy paste these yourself. Or at least, type what you see in this case because it's a VM. But anyways, RC service SSHD start. And we're going to make sure we set the password because we're going to be connecting as root. Normally you wouldn't do that, but for the install, that's totally fine. So here we're going to use IPA to get the IP address. So we set the root password, we got the IP address, and we enabled SSHD. So here we've got a terminal up on my desktop system, and I'm going to SSH from this terminal over to our VM that is booted up using our installer. So the install disk that I actually used is not the one that I wrote with to the USB drive, but it's just an ISO that I copied over to my Proxmox server. So any case, so we've SSH'd in for the first time, and there we go. All right, so disk partitioning and file systems. We're going to be partitioning and formatting the disk for UEFI and GPT. The partition table will be a bit different if you went with BIOS or MBR. And we selected XFS because it's recommended by the handbook and because it works better with the Gentoo package manager and the build process. ext4 is still totally fine, but XFS is optimal and recommended for Gentoo. All right, so this is what the partition layout is going to look like that we use. Now, this is on a UEFI GPT system. Now, quick background, UEFI is the firmware. That's modern firmware. Now, older legacy firmware would be BIOS. Now, GPT is a modern disk partitioning scheme, and MBR would be the older legacy partitioning scheme. So we're going to cover those in just a second, but basically what we're choosing here is this is the minimum you would need. You can create more partitions if you like, but those are all optional, like for var and home and stuff like that. But in any case, you're going to need your EFI partition. Basically follow what you see here. Now you can mount it on /EFI, or you can mount it on /boot/EFI. Boot EFI might be a little bit more convenient, and you'll see why later on in this video. Any case, the size is going to be 128 megs. That's a good size to set this to. That's generally what's recommended, and you're going to need to make it FAT32 to fit the specification for EFI. Now, next you're going to create a swap partition. Now, we're just saying a gig here, but you might want to do more or less depending on your needs. If you do want to have Hibernate work on your system, like if you have a laptop, you're going to want to set this to at least as much as the RAM on your system. So if you have 16 gigs of RAM, you're going to need 16 gigs of swap. So that's something to be aware of too. Now, continuing on here, we have the root. We're going to create a root partition. We're going to just, obviously mount that on root and use the remaining disk space for this partition. And we're going to format it as XFS because that works better with the Gentoo package manager. Emerge, it basically pulls down source code and compiles it. And this whole process is just more optimal on XFS. You could just as well use ext4 and it will work totally fine, but XFS is more optimal for Gentoo and for this whole process. Other distros tend to use ext4, but Gentoo XFS is preferred. Any case, for BIOS GPT, if you have an old system with BIOS, now it could be old hardware or it could be a VM. A lot of VMs and things in the cloud use BIOS. Now, if you had that, you can still combine it with GPT. GPT has fewer restrictions than MBR, so you might want to do it this way. If you do it this way, you're going to need a BIOS boot partition. Don't confuse this with the regular boot partition. A lot of people recommend using a boot partition, and we are not using a boot partition for any of these schemes that I'm showing you today. It's optional, and almost in all cases you don't need it, but it would normally hold your kernel and stuff like that. But in any case, what we are creating here is a BIOS boot partition, which is different from a boot partition, and it is only going to be 2 megs and no mount point and no file system. And that will give it a little bit of extra code that it needs to be able to find the GPT partitions. In any case, not to get too detailed on that, we also have a swap partition and a root partition, which everything I said previously about swap and root holds true for this partitioning scheme. Now, finally, we have BIOS MBR. This is the simplest. Basically, just have swap and root. That's all you really need, and it should work great. And everything we previously said about swap and root holds true for these too. So one thing to be aware of, if you have a system with BIOS and you want to dual boot Windows and Linux, you will probably want to go with BIOS MBR and not BIOS GPT. People have reported having trouble with BIOS GPT. I have not looked into how to get that working, but it might cause you a lot of trouble. So if you are dual booting, and you have a system with BIOS, you might want to do BIOS MBR or just get a newer system with UEFI. All right, so you can run this quick command here to check if you have UEFI or BIOS, and it will tell you which you have, and that's important for knowing what partitions you want and how to install GRUB. So we can also say lsblk to check which block devices we have. So you can see one of them is going to be our drive. Now here we're going to run gdisk dev sta, and we are going to create a whole new partition table. So we used an O and a Y to say yes and proceed. Now we're going to say N for new partition, select the default, and specify the last sector. To do that, we're going to specify a size, so plus 128 megs. And there we go. We're going to set the type, and this is the type that we showed you in the table before. Now N for our second partition, N for new partition, select the default, then we're going to select the size. The reason we pick default is because it's going to jump to the next partition number automatically, and it's going to set your first sector to where you left off at the end of the other partition that you just created. So the same thing here, we're going to set the type. It's going to be a different type, but you still have to set the type. Now for this last partition here, we are going to go default, and default for the ending sector. That will by default just go to the end of the disk. And we also and here we're going to print out all our partitions there, and we just went with the default partition type, so just all defaults for that last partition. Now with W to write the partition table, and a Y to proceed, and you can't forget to type W, otherwise it won't be written, so that's kind of important. All right, so next command here, we're going to say mkfs vfat-f32, so that's making a FAT32 partition for our EFI partition, just formatting it, and mk swap and swap on to create a swap device and to turn it on. And then we're going to say mkfs xfs on that third partition to format it with the xfs file system. So 3 partitions just formatted there. Now we're going to mkdir-p mnt Gentoo, and we are going to mount that Gentoo partition over an mnt Gentoo. So basically our root file system on the disk that we just partitioned and formatted will be mounted over mnt Gentoo. So we did mkdir mnt Gentoo EFI, and that's where we're going to mount our EFI partition. So right there, we did a mount dev sta1 mnt Gentoo EFI. So we're mounting EFI over the root partition. So the network temporary setup for the installation. Now the network should be working automatically from the install media, assuming you have DHCP and all your network drivers are there. If it isn't, you can try these steps. All right, so first, before we actually try those steps, we are going to just check that the network is working first, and it will be working. So IPA, that's going to show our interface. ifconfig-a does the same thing. We can see our IP address, 192.168.3.213. So that's our IP. We can see the interface is up and working. We're going to test it out by first pinging gentoo.com. You can see it pings successfully. Now, funny thing, gentoo.com isn't we really wanted gentoo.org. It doesn't make a difference. You can still test with it. But here I'm going to actually ping gentoo.org. And there we go. All right, so if you are not on the network, you can start out by just checking your interfaces with ifconfig. If you don't see an interface, it might be because it's down. Just use ifconfig-a. If you want to use a more modern new tool, you can use ip-adder, depending on your preference. Now, if no interface shows at all, you could potentially insert the driver for your interface. You're going to have to be familiar with what driver you want and what driver you need. So your mileage may vary here, but you can check using this right here. You can check this directory to see if a driver, see what modules are available and if one for your network card is there. And you could insert it like this using modprobe, assuming this is the name of your driver. Swap in your driver name as needed. Now, once that's done, you can check if the interface is up by just checking if there's a file created here, or you could just use ifconfig again. And you can also use ifconfig to get information about a specific interface like this. Now, once the interface is up, you can and you can just skip this whole driver section. If you found your interface but you don't have network connectivity, you can just skip ahead to DHCP. If you do want to use DHCP, just say DHCP D ETH0, and that will, assuming that's your network name, your network interface name. That will tell your interface to receive DHCP info, and that should get you an IP address. And if you want to use an easy tool, there is a tool available on the install media called net setup. So you can just run net setup in your interface name, and that will just lead you through setting up your interface. That might be the easy way to go if you prefer that. Now, if you want to bring up a static interface, you can say ifconfig eth0 or whatever your network interface name is, specify the IP address, the broadcast, and the network mask, and tell it to come up. That will bring up your interface with that IP info. You'll need the correct info for your network. And next, you're going to need to add a default gateway if you're doing static IP. So say route add default gateway and the IP address of the default gateway. And that should get you online with the static IP if all the information is correct and your interface is up. So you're also going to want to make sure you have something set in your etcresolve.conf file so you can resolve DNS names. So basically edit this unless you got something from, if you got something from DHCP, you might want to stick with that. If you didn't, you're going to want to set it manually yourself, or you might want to override it anyways. A good choice these are Google's DNS servers, and they work great. You only need one, but you can have a second one as a backup. Just add these 2 lines to your etcresolve.conf file, and that should allow you to that should point you to these nice public DNS servers that will get DNS working for you. That's basically everything that we're going to show you today to get networking up and running temporarily so you can continue on with the installation. Now, tarball and mirrors. We're going to need to download and unpack the stage 3 tarball. Now, apparently stage 1 and 2 tarballs aren't used for normal installs anymore. They're only used for internal development and new architectures. So the stage 3 tarball basically contains all of the basic files and packages needed to get started. Then we're also going to go ahead and select a mirror after that. All right, so paste this in and cd to our mnt Gentoo directory, and then paste this in right here to wget the stage 3 tarball. Now notice it fails. That's because it's a dated versioned tarball and they have replaced it with a more updated one. So we are going to move the downloads page right over onto the screen here. And now this is the stage 3 tarball that you would want if you wanted everything to get you ready for a desktop profile, right? Now, you could also choose the first one there for OpenRC if you wanted the minimal stage 3. Now, that's the one we're going with in this installation. If you wanted a desktop, make sure you get the desktop one. You could still use either one, but it'll just make it easier for you. So, any case, really, I don't know if you could see me copy and pasting the name of it there. I'm not sure if that was how visible that was, but in any case, basically I got the newer. Now I'm going to type wget and paste this in here. That's the new path to the updated tarball. That's the reason we went to that site, so we could grab the actual updated path to the tarball and paste it in there. Notice it went really fast because I kind of fast forwarded the video. And you're going to see that a lot. So here we are going to untar the tarball. And if that went too fast, just check the link in the description for the instructions so you can copy and paste too. And here we're going to run this nice tool called mirror select, and notice it redirects the output and appends to our portage make.conf file. So it gives us a nice tool to select mirrors, so you don't have to go searching for the mirror online and paste it into your config file if you don't want to. So this is a really nice tool and makes things really, really convenient. So obviously pick something that's geographically closer to you so it will be faster. So here I'm in New York City, and I don't recall seeing anything exactly close to New York, but the closest thing I could find, I think, was MIT, and anything else was almost just as close. So I just went with one of the MIT servers, and I made sure to choose HTTPS because I guess that just makes me feel more confident that it's not being tampered with. So I'm pulling it down from MIT, so I'm selecting that mirror. All right, so here we are going to cat the mnt Gentoo etc portage make.conf file. It's our main Portage configuration file. Notice we see Gentoo mirrors is set to the MIT mirror that we selected in the tool just before. So we could have configured that by hand if we wanted to, but we didn't. But that was the result of what we did. Now we're going to create this directory, and instead of dash dash parents, we just say dash p. But we're creating this Portage repos directory. Then we're going to copy. Mount file systems and chroot. In this step, we mount a bunch of needed file systems, things like dev and proc, and then we enter the chroot environment. The chroot environment is where we change the root of the entire system to be the root partition that we created on our target install disk, on the disk that we're installing the operating system onto. All right, so here we're going to copy our etcresolve.conf file. So we're using a --g reference in case it was a symlink. It's going to copy the actual source file rather than create a new symlink. And now we are going to mount proc and mount sys. And mount it again, but with a make rslave rather than rbind. And now we're going to mount dev. And then again, same deal. And then we are going to mount run and run again. Normally I would just copy paste all of these commands and paste them all in one shot. I'm doing them one at a time for the video. Now we run chroot on the current directory, which is mnt Gentoo, which is our root system on the new system we're installing. Then we source the etc profile. Notice when we chrooted, we also ran bash. All right, so we're going to mkdir UEFI, and it already exists. We're just doing this just to make sure, just in case something happened, and which there, it shouldn't have, obviously. Now we're going to paste in mount dev sta1, basically mounting our UEFI partition. It's already mounted, which it should be mounting that survived the chroot operation. So, but just in case it didn't, you want to make sure it's mounted here. Now we're going to check the date. If it's accurate, you won't need to do anything else. If it isn't, you're going to need to configure cron or ntp. More info on that further at the end of this guide. So update and Portage setup. In this section, we're going to basically set up Portage, set any configuration variables that we need to, and we are going to sync and update all of the packages from the repo. So we're going to pull down the latest info on what's available from the repo, and we are going to update all of those packages. That also involves building all of those standard base packages to get our system all up to date. All right, so here we're going to use nano, and we are going to edit our portage make.conf file. So we looked at this briefly a little bit ago. All right, so we're going to paste in our make ops. So we have J for jobs and L for load factor. We're going to set these both to 4. Now, and we could also set them to 8 like this if we wanted, but I'm going to just set it down to 4. So if we had more, just to, an example of how we could adjust it, and really we should be setting it to 3 because of the limited amount of memory that we have on the system. But I'm going to set it to 4 anyways, and it's going to work totally fine. So we have 4 cores, so set it to 4, but you need to set it to the lower of 2 values, either the number of cores you have or 2 gigs per number in there. And we only have 6 gigs, which means we can only set that, see here we have 4 cores, but our memory, we only have 6 gigs. So I'm going to show you that right here. See here, 6 gigs right up there. So, 2 gigs per number. So that's, we could set that up to 3 at the most, even though we have enough cores to set it up to 4. All right, so here we're going to do an emerge web rsync, and I sped this up a lot. This is sped up like many times, like 20 times the speed, but that basically just pulls down the latest info about what packages are available in the repo and everything. Now we're going to run eselect profile list just to show you the profiles that are available. Now these are just optimal settings that make sense depending on what profile you want. Notice here we have the first one selected for the most minimal system. Now if you wanted to install something like KDE Plasma, you could select this one. You could set it to 9, profile 9 here. Now the numbers are going to be different depending on what's available, so you want to check it first. But that's I used 9 when I installed this on my desktop, but for this guide we're just going to use the first option because we're doing a minimal install. But yeah, I used 9 to set up KDE, and it gives you like settings and stuff that will make sense for that. So in any case, moving along here, I'm going to select profile set, and now this is how we would do that. And here I'm just checking again the number, even though I know it's a 9. So you could say select profile 9. I'm not going to really select that. I'm going to delete that, but I'm just showing you how you would select a different profile if you wanted to. So select profile and the profile number. All right, so here we are going to run an emerge world. So we're basically going to, rebuild and reinstall all the packages that we have selected for our system right now. So this is like I think this counts as the core of the install. This is, and I sped that up. See, it finished. That actually took a lot. I think that took around an hour or so. I didn't time it, but I think that was about an hour on this system. Might take longer with a weaker system, or a whole lot faster with a stronger system with more cores and memory. All right, so here we're going to run Portage EQ and var accept license to see the value of accept license. Now this says at free, that's all free software. So that's a bunch of other levels included in that, but anything that counts as free software will be included, but we actually need to be more permissive and include binary redistributables. So we're going to set that variable within our main Portage config file. We've looked at this a couple times so far already. And let's just paste this value in here, accept license binary redistributable. So that includes binary redistributables, but also includes all free stuff as well. And you're going to need that for firmware that we're going to install later on. Users and important tools. So next, we're going to set the root password and add a regular user. We also install Vim. This is optional, but this just feels like a good point in the install process to install Vim if you want it. You can install it at the end if you prefer. The instructions are going to be using Nano for the whole install process anyways. You could just substitute in Vim if you prefer using Vim. All right, so here we're going to set the root password. Just going to type PASSWD, enter a new password, and type it again just to confirm. There we go, we set the root password. So now we are going to create a user with a bunch of groups by default. I would stick with these groups just to start. So user created, now we're going to set the password for our user. And similar thing to when we set root's password. Now I call this user1. You could call it whatever you want. Basically make up any name you want for your preferred non-root user. Now here we're going to install Vim, so emerge-vq vim. And there we go. I sped that installation up a whole lot also, but now we have Vim installed. Now I'm going to demo it real quick just to try it out. We're not going to actually be using it for the rest of this install. We're going to be using Nano, but here we go. We have Vim working really nicely. Look at that, line numbers and everything. Really beautiful, and that's about it for that. FS tab, or the file system table. So next we set up the file system table. We could also identify the disks by UUID instead of by device name like devsta, but we're going to keep it simple and just stick with that for this guide just to keep the process, just to not overcomplicate the process any more than we have to. All right, so here we have our file system table. It's in Etsy FS tab. I've already nanoed into it. All right, so we're just going to delete these existing commented outlines and paste in our existing configuration, or the configuration that I actually want. So let's see here, just paste that right in there and see we have our 4 entries. Now the CD-ROM is not super useful, but it's a pretty standard thing to add in there. Well, you see we have our UEFI partition, our swap partition, and our root partition. Now we're going to save the file and exit on out of there. So, locale, time zone, etc. So for this part of the install, we set the locale and the time zone. If you live in another part of the world, just substitute in your own preferred locale and time zone. All right, so here we're just going to check this file and see what what locales are actually supported. And from this, like if you need to find your locale, you can search through this to find it. So next, we're going to basically just run nano and edit our locale.gen file. And you can see there's some examples in here. And we're just going to paste in. I'm going to delete all of these and just paste in my locale that I'm copying and pasting, which is the one that I put in the instructions. So I'm just going to paste mine in here. And notice I put 3 of them in there. Now we're going to select the right one later on, but I just wanted those 3 to be available. And you can select whatever other ones you wanted from that list above. You can just search through it, pick out what you need. And so here we are going to run locale gen. So this is going to generate the locales. All right, and so next I'm just going to paste this in. I'm going to run locale-a, list out the locales. So those are the locales that we generated based off of that file that we defined in our etc locale.gen. So anyways, I'm going to say eSelect locale list. And these are some options we can choose from. We're going to just select the active locale that we want. So we're going to paste in eSelect locale set, and we're going to set one of these. So here we're going to choose number 6, so ENUS UTF-8. And then we're going to rerun that same command, list them out, and that is now the selected locale. So we're going to edit our etc envd02 locale file, and notice lang equals enus utf8. That is the value we just selected before, which resulted in this being generated in the file for us. Now we could have done this manually by hand if we wanted to, but we're also going to still edit this because we want to add this lccollate variable, and that is going to define how things are sorted when you sort something in alphabetical order on the system. So that was a recommended value that I picked out of the handbook. So now we're going to run an env update and source our profile, and then just set some variables that are going to make things convenient for us. And now we're going to list out some time zones that we could choose from. So if you're not sure what time zone you are in, you can choose from these. And just the way these files are organized, this will give you an idea of what time zones you could choose. And I'm going to show you how you pick a time zone. So here I have Echo America New York, and I echo that over etc time zone. And from there we're going to say emerge --config syslib time zone data. Kernel. So in this step we're going to install, and we're going to build and install the kernel. So there are 3 main kernel approaches. So the first one is full automation approach. These are distribution kernels. They're called distribution kernels, or dist kernels for short. The second approach is a hybrid approach. It's called gen kernel. And the third approach is the full manual approach. This is probably more interesting, but slightly less practical. Now, we're going to be going with the dist kernel. This makes things easy and has worked great for me. In the past, I've been able to bring up a full desktop system running KDE Plasma without really having to worry about the kernel or mess around with it. The drivers were there by default, not the proprietary NVIDIA drivers, but they were there, and I didn't have to tweak too many things. It basically worked. Basically gives you all the normal stuff you would normally need for most systems. All right, so first thing we're going to do, you're going to use emerge and install Linux firmware. So I'm going to speed this up a lot because this took a while. So this is going at like 40 times the speed. So there we go, just finished at 40 times the speed. And that basically installed a lot of firmware for different things. including, I believe, AMD microcode. And this one is going to be Intel microcode. So that previous one includes like video drivers along with AMD microcode. This one is just the Intel microcode. And between these two, this should support both types of CPUs. You may not necessarily need the Intel microcode if you're running on an AMD system. So here we're going to edit our main Portage config file yet again. And we're going to move on down here. And we are going to paste in a use variable for grub. So this is just going to include a lot of useful things that we'll need for grub going forward when we build things. So next we're going to install a Gentoo kernel package. This is just getting a package installed. So we're going to say yes, and it's going to start building this. And it doesn't take that long. This should finish kind of quickly, and there we go. So next thing we're going to do, we are going to, this is the actual kernel. So with this, it's going to actually build the kernel for us. And I've sped this part up a lot. So this took a while. It isn't the craziest, biggest thing in the world. Off the top of my head, maybe the second largest package to build in the the base minimal install. And now we're going to install the kernel sources. Say yes and continue on here. There we go. Kernel sources installed. And now we are going to use eSelect kernel list and notice the one that we want. The kernel sources that we want are selected. Now we can verify this just checking the symlink here. We have a symlink pointing to that same kernel sources version, so that should match the kernel that we have installed on the system. So for the bootloader, we're going to install grub as the bootloader, and we're using UEFI, so it's a bit different for BIOS versus UEFI. You can check our guide for BIOS instructions. Now, we ran into a minor issue with the UEFI firmware on our VM. This was really just my mistake setting up the VM before I started the install process, but it turned out to be an interesting example. So normally UEFI firmware will keep track of the EFI variables in the NVRAM or EEPROM, basically on your hardware, right? Basically on your system board. And to simulate this on our Proxmox VM, we would have needed to allocate some storage to track this info. And that basically tracks like which hard drives it's going to boot from, which hard drives have an OS installed on them. So I hadn't done that. So basically the BIOS settings or the UEFI settings kept getting wiped every time I restarted the VM. That was a bit of a pain. So I'm going to show you how to fix those issues in Proxmox, and I'm going to show you a workaround for this issue with grub. So I'm going to show you two fixes. I'm going to show you how you can fix actual VM in Proxmox and a grub technique for working around this issue. Now, if you're installing this on actual hardware with UEFI, you're probably not going to run into this issue unless your UEFI implementation has a bug or misconfiguration or something. So, in any case, the grub workaround basically writes the bootloader to the default location on the UEFI partition instead of a custom location for that specific OS install. This way, it doesn't need to be tracked or rely on the EFI variables that are stored in NVRAM or the EEPROM. Now, this is great for use with removable disks, and it's great for systems with broken or messed up UEFI like our VM that broke, and it has a potential side effect that your OS might not show up as a boot option. So your UEFI firmware might not show it as an option when you're booting up. That hasn't been an issue for me on any system I've used this on, though. So your mileage may vary. Now, another issue that popped up is that the default location for the EFI bootloader is boot EFI boot x64.efi. So it's that whole big long path. Now it expects it to be there by default. That's where the firmware is always going to look for that default bootloader. So if it's not there, basically you need it there. And when you install grub, when you use grub to install in the default location, that's where it tries to write it on your file system. So that needs to be mounted. So it expects to find it under the boot directory. So this is a good reason to mount the EFI partition over boot EFI instead of just EFI. In my case, I create a link to get around this, but in retrospect, it might have been a better idea to just mount the EFI partition over boot EFI instead of just EFI. Now, a lot of other distros mount it over boot EFI, and in Gentoo, you can choose to do it whichever way you want. They don't tell you you have to do it any specific way, but the normal default recommended way that they show in the examples in the handbook they just mount it over EFI. So I kind of just went with that. So, but I think it's actually probably a little bit more optimal to do boot EFI, but you can get it to work either way. All right, so here we go. We are going to echo grub platforms EFI64 to our main Portage config file, just to make sure that we have that correct platform selected. I'm going to run emerge ask sysboot grub. So just install the package for grub. I'm going to say yes, and I'm going to continue on here. I sped this part up a lot because this did take a little while. And there we go, we're done with that. Now, next thing we're going to want to do, we are going to say grub install and target x86 EFI, EFI directory EFI. So this actually installs the bootloader. The previous command just installed the software for grub and compiled it. This command is actually installing the bootloader to our EFI partition, which we created at the beginning of this process. So there we go, we have that installed. So that does create a custom boot entry for Gentoo, specifically for this installation, which makes a little bit of a difference, as we'll see later. So in any case, we are going to paste in this other command here, and this is sysboot os prober, and this is a tool that will allow us to probe for other operating systems on other partitions and disks. So grub can allow you to boot in, give you multiple options on your grub menu, so you can choose which OS you want to boot into, which is kind of also a really convenient, nice thing that it does that for you. But as we see here, we ran into a bit of a config file conflict, so we're going to fix that real quick. So we're going to cd into our etc portage package use. Now, if it had actually successfully installed this, we wouldn't have to do this process, but here we go in here, we diff these two files, and we are going to go right ahead and we're going to actually move one file over the other file. That's basically going to solve the issue, and we can reattempt to install that package. Had the package just installed, and if this is not an issue with the newer version when you run your installation, you might not have to do this part if the package installs correctly on your first shot. If it doesn't, you'll just do this, run emerge os prober again, and say yes, and this time it's going to actually build the package for us. And yet again, I sped this process up a whole lot. This actually takes a little while for that to build, but there we go, we're done for now. And next we're going to edit this grub configuration file. And we are going to add right down here. We're going to paste in here, and we're going to add grub disable os prober equals false. So false to disabling the os prober, kind of like a double negative. That's going to allow os prober to actually work. So that's just like an extra step that you have to do. Now you don't really have to use os prober, but it's nice. So anyways, I'm just grepping for it to make sure it's in there and that it wasn't defined twice. And all right, so grub mk config -o and specify our boot menu, and this is going to generate a grub config file, including the probed OSs. All right, so here we're going to cut away from the installation process, and I'm going to show you how to fix some UEFI issues. I'm actually going to perform these quick fixes on a couple clones of the VM that I was working on. So I took the VM I was working on and I cloned it a couple times and tested out some things and did some fixes. I'm going to show you those now. And then when we cut back, we're going to continue on with the installation as if nothing had happened. Basically, we're going to come back to it right where we left off right at this point. So all these steps are just extra stuff you would do if you run into these issues, and we're going to show you those right now. Alright, so here's our cloned VM, and we're going to show you the actual problem that we ran into. See, you have this error message up here, basically coming from the virtualized firmware. So eventually it's going to come up with this stuff over here, and eventually it's going to drop you down into a shell like this, which you could run, I guess, UEFI commands and stuff on. But we're not going to do that. So here is Proxmox, and we can say add, and we can say add UEFI disk, and just select some storage space, and just say OK, and that allocates some storage space for our VM. And had I done this when I initially created the VM before starting the installation process of Gentoo, I would not have run into any issues at all and it would have been totally fine. So just if you are using Proxmox, you can do that. If you're not using Proxmox, then don't worry about it. But that's how you correctly create the VM. But I figured this would just be an interesting thing to show you. So long as you create your VMs properly, you won't have to deal with this yourself. And this also isn't really part of the Gentoo install, but it's an interesting kind of related issue. So it's worth looking at. And it does help understand the system, the bigger picture and how everything fits together. So it's just good to cover it. So I sped this boot process up a little bit because it takes a while when it's having this issue. Anyways, when you get to the shell, you type exit. You're going to exit out of this UEFI shell. And go to boot manager, boot options. You're going to add another boot device, say edit, go down here to Gentoo, go down here to GRUB 64 EFI. We're going to give it a label. We're going to commit our changes. Then we are going to change the boot order. We're going to select it up here. Notice we have a Gentoo option right there, and that points to the actual bootloader that we installed on our EFI partition. So we're basically just telling it to, here we go, reset. Basically what we did, we just told the firmware to, it told the firmware where to look to find the bootloader that we installed on our EFI partition. Now that we've done that part, it's going to remember it since we added storage to the Proxmox VM. It is now, we're able to remember that. Now, had we set that without giving storage to the Proxmox VM, it would have basically wiped it, and every time we reboot, it's going to forget where the bootloader is stored, and it won't be able to boot up. But since we were able to, now we can reboot the system as much as we want, and it will remember the location of the bootloader on the EFI partition. It's going to keep that boot entry in there because it has the VM has some storage space allocated to it, and it's able to store things in basically emulated or virtualized NVRAM storage. So basically that's what's going on there. Had I allocated that storage at the beginning, I wouldn't even have to go into the UEFI settings like that and set those values. I wouldn't even have to do that in the first place. But if you're fixing it, you would add the storage and then go in and fix it, and then it's going to remember it, and then you can just continue on and everything should work fine. Alright, so sped that part up a little bit right here, and now we are at a login prompt. We're going to log in, we're going to halt the system, and we're just going to verify that we can reboot it again, and that it will come up and remember where the bootloader is. So I'm going to log right in here, halt the system. It's going to shut down. And then we are going to basically just right click on this and start it back up again. Fast forwarding here a little bit. just like always. And there we go. We're at the login prompt again. So we can just log in, and I mean this pretty much proves that the system can boot up again and that we pretty much resolved the issue. So here's an alternative fix in case you didn't want to fix your UEFI BIOS like we did before, or in case you wanted to get around another issue or create a removable device. So notice here it says error cannot find EFI directory. Now this above command was the same command we ran before, except it has a dash removable on the end of it, so the option's a little bit different. But this installs your bootloader to a default location, and the reason it couldn't find the directory is because it's looking for it's looking for under boot EFI instead of just EFI. So the path that we mounted our EFI partition on is not what it expects. So yeah, see here, it's trying to install the bootloader like we did before, but before we used a custom boot entry. Here we're just using the default entry, so that's not going to work out. So we're going to get around that by creating some directories and creating some links. So, and here I am just typoing things while I record myself, but yeah, hold on here. Yeah, I'm kind of fumbling over what I typed here, but in any case, actually cd into the boot directory in ln-s EFI, so that creates a boot EFI directory instead of just the EFI directory. So anyways, created a link instead of mounting it at an alternate location, and now we can run grub install target x86 64 and dash removable, and this will actually install it. Now the dash removable option installs to the default location, just as if you were creating removable media, like if you were to install grub onto a USB drive. That's an option you would use for that, and it may or may not create it may not be picked up as a boot option by your firmware, or it actually, in my experience, has worked just fine. Any case, that is yeah, and you are going to need to recreate your grub config file. So grub mkconfig, basically run this over again. And yeah, I've had no issues with it. So there are potential downsides, but it for the most part works fine. It's not the right or correct or quote unquote optimal preferred way of doing things. Normally you would want to actually create a specific boot entry. And so from here I've rebooted, and I'm basically, all I do at this point is just reboot the VM a couple times just to prove that I fixed the issue, and we've already watched me do that a few times, so we don't really need to do it again. So we are going to cut back now. So here we're going to be cutting back to the normal Gentoo installation process as if nothing had happened, because in most cases you won't run into this issue, you won't need to fix it. So you can kind of just continue on with these instructions as if nothing had happened. Had I created the the VM correctly before running this installation, I basically wouldn't be doing any of that stuff, and it would just continue on like normal. So basically this is the point in the video where we cut back to the normal installation process. All right, so the network. So for the network setup, we will set up the host name and the host's info. We're going to set up DNS resolution in etcresolve.conf, and we're going to enable DHCP. We also install some useful network packages, including wireless utilities. These aren't really useful on a VM, but I just wanted to illustrate getting them installed. And we aren't going to be covering Wi-Fi or static IPs, but you can just check our guide linked to in the description for info on how you would do that. I'll probably have a separate video covering these things coming up in the future. All right, so here we're just going to echo a host name into our etc hostname file to set the host name for the host, and just show what we set right there. Now, one thing I'm going to point out here, I kind of the names are a little bit inconsistent here, so you'd want to keep your names consistent when you actually do that. So I kind of messed that up. But we're going to define some example names here in our etc hosts file. So basically, I was going to call this Gentoo test 2 and then say Gentoo test 2, and I was going to put a domain name on one of these. So I would say like example.org. Now, I decided to just call it test2 rather than Gentoo test 2. And now, to be consistent in the hostname file that we configured prior to this, I should have called that test2 rather than test1. But in any case, just make things consistent. Choose whatever name you want, but be consistent. All right, so here we're just going to cat out our etcresolve.conf file. Notice we have some values in here supplied by DHCP, so if you do have those, you can choose to stick with them if you want. This is actually the preferred name server because this is coming from my DHCP, my own DHCP server, so it's giving me, the preferred settings that I prefer myself. But if you were to set this manually, a name server of 8.8.8.8 is a good choice. It's a public domain server. It's one this is one of Google's public domain servers, and I feel like they're more trustable than your ISP's name servers. So here is a backup name server 8844. So you can add a primary and a backup, and you do it like that. Now, good chance that gets overwritten the way we have. That's actually a little bit better than what DNS gave me, but yeah, good chance that's going to get overwritten if we continue to use DHCP. So I could either fix my DHCP server, or probably use static IPs or something like that. All right, so clear the screen real quick, and we are going to emerge and install some network-related tools and packages that I think you should have on most systems probably. Although on a VM, we're not going to be using any of these wireless packages. There's a lot of these are just tools for wireless, and those are useless on a VM. You might want to exclude those if you're installing a server, a VM, or even a desktop. But I included them just to show you how you do it because they're really handy if you're installing this on a laptop or something with Wi-Fi. So anyways, we're going to run rc update add DHCPD default, assuming you're using DHCP. I say rc service. You basically start the DHCP service. It's already running, so it gives us that message, but that's fine. Any case, if you are you going to be using DHCP, this will pretty much get you all set with DHCP for when you restart the system. Really, you only had to add that as a default, basically enabling the service. You didn't actually have to start it manually. So basically finish the install and wrap up. So this isn't really the end, because in the next step we will cover installing basic standard components that you would want on most any systems. You can perform all of these steps in the basic standard components section before actually exiting the chroot and rebooting your system. You could do that if you prefer, or you could go ahead and reboot the system in this step. Up to you. So you can also leave them till the end if you like. That's the order we're going to do. We're going to install those basic standard components after we exit the chroot and reboot. So here we're going to wrap up the install by exiting the chroot, rebooting the system, and cleaning up the stage 3 tarball. Then we're going to move on to basic standard components that we want to install. All right, so here we're going to exit out of this shell. So just left the chroot environment by exiting, and a cd out of that mounted directory. And we're going to unmount some directories. Unmount our root directory, or our root partition, which was mounted on MNT Gentoo. And then we're going to reboot. All right, so speeding this process up a lot. So just fast forwarding through the boot process, and there we go. We have a login prompt. So we're going to log in as root. And there we go. Now, first thing we're going to do, we're going to start up SSHD. Now, this is one step we could have done. We could have enabled it before restarting. But in any case, start up SSHD, check our IP address because there's a good chance it changed since since we last booted. So now we're going to SSH back into the host so we can continue the process, because remember, we're not done yet. A few more things we want to get done. But there we go. We're logged into our system. I'm going to su to root. Kind of muscle memory. I'm used to typing sudo su, but we don't have sudo installed. So we're just suing to root. And clean up the stage 3 tarball before we forget. So basic standard components. These are standard normal components that I would generally expect to be present on most systems. These are usually a good idea to install, and you could install these before restarting the host if you like. Note that your IP address may have changed after rebooting the host. So if you want to SSH back in, just check what the IP is before doing that, especially after exiting the chroot environment and all that. So in any case, we are going to install and set up remote SSH access, PCI utils, logging, cron, file indexing, shell completion, cronny NTP, file system tools, and a little bit of extra device stuff, and that's going to be about it. All right, so here we're going to emerge, basically install PCI utils, just useful hardware related utilities that you're going to want to have on your system. I think everyone should have them on their system. So we're going to fast forward through this and it will be installed in a sec. And there we go. All right, so here we're going to install sysklogd, so we have a logging daemon installed, kind of an important thing to have on all systems. There we go. Fast forward through that and we're all set. So now we're going to install, we're going to actually rather add that to the default run level so it will start up on boot. And now we're going to install cronny. So you want a cron daemon running. That's kind of an important thing to have on most systems. So there we go. And next we're going to enable this to start up on boot as well. So add that to the run level. And next we are going to install mlocate for indexing of files so you can search for things more quickly. And there we go. Installing bash completion. Installs pretty quickly. I did speed that up a lot though. And installing cronny, spelled with a Y. So this is going to be for NTP and stuff. And enable that daemon on boot as well. All right, so here I'm installing a bunch of file system utilities for different file systems. I just feel like it's nice to have those on the system in case you need to deal with any disks that do have those file systems. It's just a thing I like to have on there. Personal preference, you don't need all of them. And this last bit is for scheduler behavior with NVMe drives. So basically, it's for UDEV rules. I don't think I'll be using those, but it's something that's recommended to have installed. So now we're just going to run uname and just check out our newly installed system. So there we go. There's like our kernel version and everything else. And check our CPU cores, our memory. Just kind of poke around and look at what's on the system. So now we're going to install neofetch with emerge. Just going to paste this, or rather type this right in here. And type yes, continue on. Should be done relatively quickly. It's not a huge package, not a whole lot of compiling going on there. But there we go. And so let's give it a try here. View all our system info. There we go. There is our first run of neofetch. We're also going to check, etc Gentoo -release, Check uname again, clear the screen, and redisplay. So there's our system, our OS, our host type, KVM. We've got our uptime, 350 packages installed. So hopefully you found this useful, if not interesting, and hopefully this helps at least somebody install Gentoo. Now, if this helped you, give me a thumbs up. If you know something I don't know, leave a comment down below and let me know, not just for me, but for anyone else watching this video. Anything you have to add to the conversation, anything you want to say, comments, questions, criticisms, just leave a comment down below. We want to know what you think, and a lot of other people probably want to know what you think as well. So also, you might want to hit that subscribe button so you don't miss out on our other great Gentoo content. We're going to do a lot more how-to videos, show you how to do things. We're going to probably be setting up X11 on video soon. We're going to show you a bunch of other things you can do with Gentoo, and a lot of other just Linux stuff in general that you're not going to want to miss out on. So hit the subscribe button, hit the bell icon, otherwise YouTube won't let you know when we come out with new videos. And also, we have a ton of other great content coming out, not just Linux stuff, not just Gentoo stuff. We cover Raspberry Pis, electronics, hardware, software, servers, desktops, coding, automation, 3D printing, networking, all sorts of great tech stuff that you're going to want to have in your YouTube feed. So definitely hit that subscribe button. And that's about it for today. So as always, thanks for watching, and we'll see you guys on that next video.